So dear students, so in EDC lab we are having PN junction diode VA characteristic experiment. So in this experiment we have to plot the VA characteristics of a given semiconductor diode in forward as well as reverse bias conditions. After that we have to find cut-in voltage, then we have to find static and dynamic resistance from the graph. The forward bias, we can connect the PN junction diode in two ways. One is forward bias, that is as shown in this figure. So this is anode, this is diode, this is anode, this is cathode. Anode is connected to external battery, that is positive terminal of the battery. Cathode is connected to negative terminal of the battery. This connection is known as forward bias connection. Now coming to experimental setup in the laboratory. So we have to, this is anode is connected to positive terminal of RPS. Cathode is connected to negative terminal of the regulated power supply, that is RPS. Now obviously it is connected to ground point. Now to measure the voltage, we have to connect a voltmeter. The voltmeter is always connected in shunt form. Therefore, across the diode we have to connect the voltmeter. So this is in shunt form. So similarly, to find out, to measure the current, we have to connect a meter, that is called ammeter. Ammeter is always connected in series as shown in figure. So here the apparatus, so we have to take one RPS, so one limiting resistor 500 ohms, one diode generally BY127, so one voltmeter having 0 to 1 volt range, one ammeter 0 to 30 milliamperes for forward bias circuit, for forward bias circuit. So now procedure to take the forward bias characteristics. So connect the circuit as shown in the figure A. Now after that vary the regulated power supply so that the reading in the voltmeter varies in steps of 0.1, not 0.05. If you take 0.1, and for each voltmeter reading, note down the ammeter reading, that is voltmeter reading is taking as VF, ammeter reading is taking as IF. Now tabulate the values of forward voltage VF and forward current IF. So after taking the values, now plot the graph between VF and IF on a graph sheet. So after that we have to find out the cut-in voltage, where the current rises suddenly, that voltage is taken as cut-in voltage V gamma. That we have to take from the graph. So after that calculate static and dynamic resistance from the graph. How to calculate? So I will show after drawing the graph. Now, so this is the circuit. For this circuit, our lab circuit, all of you look at this circuit. So this is RPS, this is RPS. So this is the circuit. So here we had, for forward bias we have to take 0 to 1 volt, 0 to 1 volt voltmeter, and 0 to 30 milliamperes ammeter. So one voltmeter having the range 0 to 1 volts, one ammeter 0 to 30 milliamperes, one RPS and circuit diagram. Now come to circuit diagram, actual circuit. So this is the, take the positive, so connect to the, so as per this circuit, positive terminal of the RPS is connected to one resistor, this is positive, red white is positive, connect to R as per our circuit. This is resistor, 500 ohm resistor. So second end of the resistor is connected to the ammeter, that is, so this is connected to the ammeter. So this is red wire, this is black wire. We have to connect the ammeter like this, ammeter. So after that ammeter, second end is connected to diode. So this is diode connection. So here, so this is the diode. So this is the diode. So here in this circuit, so here this point and this point is connected back. So here back side, So this is, so these 2 points are connected. After that, so this point is connected to anode of the diode. So here connection is from this point to this point, so this point to anode, whatever it may be. So there is a, so ammeter, there is a connection between ammeter and anode of the diode. So this is the ammeter to diode connection. So diode cathode is connected to ground point. This is ground point is connected to the, so negative terminal of the battery. So this is black wire, negative terminal of the battery. Now we have to connect the voltmeter across the diode in shunt form. That is, so this is the voltmeter. So this point and this point is connected here. So this point and this point, so here connected back in the back side. So here, so this is the ground point. So these 2 wires are connected to voltmeter. So remember that by connecting this one to this connection, so this circuit will connected in forward bias, So leave this black wire. So these are the connections for forward bias circuit. Now we have to take the readings. So this is the table. So these are the forward bias readings. These are reverse bias readings. First see the forward bias readings. We have to take forward bias voltage, that is VF, in 0, 0.1, 0.2, 0.3, 0.4. So like this. We have to take equal number of steps having the value 0.1, 0.0, 0.3, 0.4, 0.5, like this. For each value of forward voltage, so measure the ammeter value. Now I will show the values. First 0, 0. So put, so here 0, 0, this is 0. So after that, just rotate the RPS to 0.1. 0.1. So then also ammeter value 0. So like that 0.2. Next reading 0.2 by rotating RPS. For 0.2, so then current also 0. Like that you have to take 0.3 volts for 0.4 volts for 0. So up to 0.4 we will get 0. Now come to 0.5. So a small current 0.25 milliamps. 0.25 milliamps. So then 0.6. So take the values for 0.6. For 0.6 we will get 1.5 milli. So then 0.7. So we will get 8 milliamps. So then 0.78. So we will get nearly 20 milliamps. So finally we will get the values. So tabulate all the values in the tabular column. Now for these values we have to draw the characteristics on the graph sheet. So this is the forward bias characteristics. So divide the graph into x-axis and y-axis. So according to the values, so on x-axis take each unit 0.1 volt, 0, 0.1 volt, 0.2, 0.3, 0.4, like that. So on x-axis according to the values, divide the y-axis scale so into 1 unit as 2 milliamperes. So write 2 milli, 4 milli, 6 milli, 8 milli, like that. So now locate all the values according to the table column values. So locate first value 0, 0, 0.10, 0.20, 0.30, 0.40, 0.5, 0.25 milliamps. So 0.6, 1.5 milli. So 0.75 milliamps. 0.78 20 milliamps. So locate all the values and draw a freehand sketch. We will get the forward characteristics, forward bias characteristics like this. So this is the graph for forward bias connection, forward bias connection. Now from this graph we have to find out the cut-in voltage. Cut-in, what is the cut-in voltage? The forward voltage where current rises suddenly. So observe this graph up to 0.4 volts current is 0. After that, so current slowly increases. So at 0.6, so since this is a silicon diode, at 0.6 current rises suddenly. So we can take 0.6 as cut-in voltage, V gamma cut-in voltage. Now after that we have to calculate the static resistance and dynamic resistance. So as per our calculations, so static resistance is V1 by I1, dynamic resistance is V2 minus V1 by I2 minus I1. Now from this graph take any point in this sudden rise curve. So if take this one as V1, this is I1, V1 by I1 gives us static resistance. Take any two values, this is V1, take another point V2, this is V2, this is V1, similarly this is I2, this is I1. So take these values, now we can calculate static resistance is V1 by I1, 0.7 volts by 6 milliamp. So that is we will get 116.7 ohms, so nearly 120 ohms. So dynamic resistance V2 minus V1 by I2 minus I1, that is 0.78 volts minus 0.7 volts divided by 16 milliamperes minus 6 milliamps. So finally we will get the value 8 ohms. So this is the dynamic resistance. So these are the values we have to take forward bias characteristics. What are the values you have taken from this forward bias cut-in voltage and static resistance and dynamic resistance. So this is about forward bias characteristics. Now come to reverse bias circuit. Now, so this is the reverse bias circuit. What is reverse bias? So anode is connected to negative terminal of the external battery. Cathode is connected to positive terminal of the battery. So this is reverse bias characteristics. Reverse bias circuit. Now if you come to lap circuit, that is cathode is connected to positive terminal of the RPS, anode is connected to negative terminal of the RPS. Now to measure the voltage we have to connect one voltmeter in shunt form. To measure the ammeter we have to take one ammeter. To measure the current we have to take one ammeter. So here ammeter range is 0 to 30. Remember that we have to take correct voltmeter and ammeter ranges. So 0 to 30. So here 0 to 500 micro amperes ammeter. So connect the circuit as shown in this figure. So vary the RPS so that the reading in voltmeter varies in steps of 2 volts like that, 1 volt or 2 volt. So I will show the readings, model readings in the tabular column. So after that tabulate the values of reverse voltage, not forward, reverse voltage and reverse current. Tabulate the values of reverse voltage and reverse current. So plot the graph for the obtained values. So these are the values for reverse bias. These are the model values. So for 0 0, so here circuit, our lab circuit, just to switch off the circuit, then switch off the circuit and take out this forward bias connection. So here we are using another diode. So this is the diode which is connected in reverse bias condition. Just to reverse the circuit, just to take out this blue wire and put this black wire, then so remaining circuit, this is the diode, so which is in reverse bias. So now change the meters, voltmeter and ammeters. So for this one voltmeter reading range, we have to take 0 to 20 or 0 to 30. So here I am taking 0 to 30 volts, and for ammeter I am taking 0 to 100 microamps ammeter. So remember that here 0 to 30, 0 to 100 micro, 0 to 30 was voltmeter, 0 to 100 microammeter. Now switch on the circuit. Now first take the first value 0 0, first value 0 0, first value 0 0. After that, so keep the value at 1 volt, 1 volt. So then we will get 1 volt. So 1 volt, 2 volts, 14 volts, 1 volt, 2 volts, 4 volts, 10 volts, 15, 20, 25, 30. Note down the ammeter values. Now, so I have tabulated some model values in this tabular column. For 0 volts, 0 amperes, microamperes. For 1 volt, 2 micro, 2 volts, 14 micro, 4 volts, 14 volts. Whatever the values we got, just to note down in tabular, in the table. Now for these values, now take the graph sheet. Now this is VR, this is IR, reverse voltage versus reverse current. So since both are negative, we will get the curve in the third quadrant. This is first quadrant, second quadrant, third quadrant. So now according to the values, we have to select this scale. So on the x-axis we have to take, so here 0 to 30 volts, therefore I am taking 5 volts, each unit 5 volts, each unit has 5 volts, therefore 0 volts, 5 volts, 10 volts, 15 volts, 20, 25, 30 volts. So on the negative y-axis I am taking 0, 10 micro, 20 micro, 30 micro, 40 micro, 50 micro. Now locate the values. Locate the values as per the tabular column. 0 0, so 1 2, so this is 1, so here we will get 1, 2 micro, 2 14. So like that, locate all the values, we will get the curve like this. So this is the reverse bias characteristics. So now if you look at this total graph sheet, so this is forward bias characteristic, this is reverse bias characteristics. So we have to write the scale, we have to mention the scale also. For forward bias on x-axis 1 unit is equal to 0.1 volt, on y-axis 1 unit is equal to 2 milli. For reverse bias on x-axis 1 unit is equal to 5 volts, on y-axis 1 unit is equal to 10 micro. We have to mention the scale also. According to scale we will get the graph. So these are the forward bias characteristics and reverse bias characteristics for a given PN junction diode.